Hello, I'm Kainton, the Tech Pro. Today we are going to be talking about Introduction to Programming Languages, or you can put it this way, Introduction to Computer Programming. That will be the topic for today. And one thing I would like to let you know is that you don't need to be a computer programmer for you to write computer programs. You don't need to be a software engineer for you to be able to write computer programs. If you follow my course, you'll be able to write a computer program, whether you're a beginner, whether you're an amateur, be able to write a full-fledged computer program. Although it may not be a very advanced one, you'll be able to write a program that runs perfectly in the computer. And it may not be that you can write in every programming language, but for the ones we are going to discuss in this class, you'll be able to write a program. This will actually be a two-part course. The first part will be 20 to 30 minutes lectures, and then we use about 15 minutes for our lab work. And then the next part will also be 20 to 30 minutes for the lectures, and then we use 10 to 15 minutes for the lab work. And then I've done it in such a way that we'll take 3 programming languages per session. So for this one, we'll take some introductory notes, and then we take about 3 programming languages, then we go ahead to do the hands-on. So let me put some things together, then we start discussing what exactly is computer programming. Alright, welcome back. Let's now discuss what really is computer programming. This is a topic that many persons have not really been clear on. Many kids, if you ask them, do you want to be a programmer? They don't even know what a computer programmer is. A computer programmer is somebody that writes a program for the computer. Somebody that teaches the computer how to do things. So, programming. Writing computer programs, and the next logical questions will be, what are computer programs? For us to get that question correctly, we need to go back in time to the early days of computers. Also, we need to get a clear understanding on how computers works. One thing you want to know is that a computer is a piece of electronics. Just like you have your television, you have your radio, you have your CD player. All of them are pieces of electronic devices. And electronic devices have to do with electronic signals. So it's just several tiny cables running inside the computer box, and that's all. No matter how complex it is, it's just tiny cables running from one point to another. The same way you have cables running inside your roof from one point, lighting point to another, that is what it is. So the computer understands on and off. Anything electrical or electronics understands on and off. Either there is a signal in the cable or there is no signal in the cable. So that brings us to the question, what language does a computer understand? The computer understands ones and zeros. Okay? The computer understands a language of ones and zeros. So if we want to talk about what alphabets does a computer use? Is the alphabet made up of 2 figures, a 1 and a 0. So that is the language of the computer. So in the early days, very much early days of the computer programmers have to write instructions that actually is made up of several ones and zeros, and then the computer is able to understand it. So a 0 means that a signal is flowing in the cable. A 0 means no signal is flowing. A 1 means signal flows. But then, how do you think it's going to be when everyone is writing programs, ones and zeros? If you have a notebook filled with ones and zeros, how do you think it will be? How readable is it going to be? So that means that there is a need for us to write a program that is a little human readable. That is, we want to write a program that humans can understand. So since we need to write a program that humans will understand, then we need a way to map a human readable program to a computer readable program. Okay? So a programmer must understand these concepts, that a computer understands this language of ones and zeros. The real name is binary. Understands binary. This is the language of the computer, whereas we understand human readable languages like English, French, native language, this is spoken in Nigeria, and so on and so forth. So this is the language humans understand, and this is the language computer understands. So there must be a way to write a program in human readable language and then convert it to a computer readable language. And that brings us to the next topic: what really is involved in converting this human readable language called high level language to a computer readable language called a low level language. So that will be the next thing we are going to discuss. Maybe you can grab a pen and a paper so that we start discussing how to convert a high level language to a low level language. What we are now going to discuss is how do you take this high level language that humans understand, converting it to a low level language. Let me give you an example. For instance, if you are writing computer program, you may have to write something like print sum, okay, in line 1, okay. If you are a computer programmer, this may be something you write. But writing in the computer system, in the computer logic, it may be a string of zeros and one, and so on and so forth. Okay, so how then do you convert this? The computer doesn't understand this. This is what the computer understands. So how do you convert this high-level language to low-level language? Another name for this is also machine language, because this is a language the machine understands. Okay, so that is the point. So now we are going to discuss the process of compilation, assembly, and interpretation. Let's take the first one, compilation. Compilation means, in simple terms, converting a high-level language to a low-level language. And now we have discussed this binary language of the computer. That is the lowest level language, but there are other levels. We also have this assembly language. Assembly language is also a low-level language, but it is not a machine language. Before an assembly language will be understood by the computer, it has to be converted to a low-level language. So, for you to convert this high-level language to any of this, you do it by the process called compilation. Okay? So, compilation is handled by a compiler. So if you are writing a program in high-level language, you actually need a compiler before it can be converted to a computer-readable language. So compilation is converting a high-level language to a low-level language. So the print sum you've written your programs, or you can say even if you've written a Java program, you have something like int x. When you define x as an integer, this will be converted to series of ones and zeros through the process of compilation. So what compiler does is going to read everything one line after another, one figure after another, and then transforms them into a low-level language, and that is the process of compilation. Sometimes a compiler may convert in stages. It first converts from the high-level language to an intermediate language, and then it converts from this intermediate language to a low-level language. Well, how it does it is not important. The main thing is the compiler converts a high-level language to a low-level language, and that is one thing you must understand. That is the work of a compiler. The next thing I'm going to talk about is assembler. I'm not going to spend much time talking about assembler, but an assembler converts a high-level language into an assembly language. And now the question now is, what is an assembly language? An assembly language is a language that is intermediate between high-level and low-level. It's more or less a language that tends to talk to the hardware, but not in terms of ones and zeros. Some look at it in terms of a language used to control the registers and the memory. For instance, you may have, in assembly language, you may have expressions like 1 loads A, 2 adds B, 3 okay, you may also have a store C. Okay, so something like this is referred to as an assembly language. Sometimes a programmer may not write exactly this. An assembler might convert a high-level language to this. In the early days of computers, we have programmers writing assembly languages. For instance, in the days of ENIAC and the days of early days of Bill Gates, when Bill Gates developed the operating system of the Apple II computer, it was written in assembly language, and that is not really assembly language, but something like that. In BASIC, BASIC was a high-level language, but I think the syntax looks something like this. So an assembler converts a high-level language to an assembly language. Alright, the next one now is interpreter. Take note of these 3 points. We have a compiler, we have the assembler, then we have the interpreter. An interpreter interprets a high-level language line by line. It doesn't need to convert all the codes written to a low-level language. It interprets it and executes it one by one. An example of an interpreted language is the DOS commands. For instance, if you go to the DOS prompt, just give me a second, let me clean off this. If you have used Microsoft DOS before, you may know about, in the command prompt you have something like dir. Okay. When you type dir on the command prompt, what do you expect? You expect the system to list all the files in that directory, and that is the directory command. What happens is that you've written a one-line program, a high-level language of a single word, dir, and right inside the computer machinery, it converts it immediately and executes it immediately. So there is no long process of converting to intermediate and then producing an object, producing a machine code. It interprets it and executes it. So the subsystem that does it is called an interpreter. Okay. So sometimes this machine language, you never got to see it. It's a representation that is used internally by the computer. Sometimes the machine language that is generated is also called object code. Object code. And the high-level language written by the programmer is called the source code. I think you need to get this correctly. We have the high-level language is called the source code, written in a programming language by a programmer, and this gets converted to a low-level language called the object code. So we've discussed about compilation, we've discussed about interpretation, the compilation, assembler, and also an interpreter. So these are the three concepts you need to know, the basic concepts of computer programming you need to know. So let's now take some time to take a review of the computer mathematics. That is, how does this thing work internally? And that brings us to number systems, and that is what we are going to discuss next. Alright, this is what we are going to start with at this time. Number systems. This is not core mathematics. Remember, the difficulty level of this course is easy. So don't think I'm talking about mathematics and tune off. Just follow along and you will understand how easy it is. In my other video, I explained why mathematics is the most fun subject in school. I mean it. Mathematics is not that difficult. Meanwhile, that is not what we are talking about here. We are talking about computer programming, what computer programming is, and we are talking about converting high-level language to a low-level language, writing computer programs in high-level language or assembly language and getting it converted. But we want to briefly see the number system of the computer. How does the computer really handle this? And why you need some review of mathematics as a computer programmer is, at one point or the other, you may have to write programs that solves mathematics. For instance, you want to calculate employee salary for the month, or you want to calculate discount or the exchange rate converting from one currency to the other in some transaction. So a brief review of mathematics is in order, but one thing is not difficult. What I'm going to explain to you is not difficult. So the first thing we are going to look at is number basis. Alright, when we use numbers, we mention your age. I'm 30 something years. I was born in 1984. I was born in 2001. We're actually using a number system, and that is based on 10-digit number. What it means is that we have 10 digits we are using. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. This is base 10. The reason is because 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So the most common or most popular number base is base 10. That is the everyday number base everybody use. So when you say something like you bought something for $2,000, is actually $2,000 base 10. But since that is the most common number base we are using, we will not write the base. So just take note that anytime, any day you mention a figure, take note that you are working in base 10. So whatever number you mention today, whether it's your age, whether it's how much you want to pay the taxi cab, whether it's how much time you've watched this video, take note that you are saying that number base 10, because that is the most common number base. Another number base is base 2. Let's look at base 2. Okay, base 2 uses only 2 figures. Base 2 uses only 2 figures. That is 1, 0, and 1. So no matter whatever number you want to represent, it can be represented in base 2. We are not going to spend time discussing how to convert between the two bases. But take note that if you have any number, you can convert between the base 2 to base 10. You can also convert base 10 to base 2. Let me just give you a simple example. if we have something like 1 1, okay, 1 1, and this is base 2. The reason it's base 2 is because it's only, assuming you have 1 1 to base 2. What does it amount to in base 10? Okay, let's do it as a little exercise. Let's do a little exercise. Convert 1 1, which is in base 2, to base 10. Okay? What you simply do is you write out the two figures and then divide and then put 1 2. Okay, so 1 1 to base 2 is 1 plus 2. 1 plus 2 equals to 3. So what it means is that 1 1 to base 2 I think I'm getting it wrong. Let's see. 1 1 to base 2 is equal to 3. Yeah. 1 1 to base 2 equals 3 to base 10. Alright, I promise this is going to be very simple. So let's forget about all of this conversion thing. Let's just proceed. We've discussed base 10, we've discussed base 2. We also have base 4. We also have base 4, and that uses 0, 1, 2, 3. We also have base 8. It uses 0, 1, 2, 3, 4, 5, 6, 7. And then we have base 10. I've mentioned the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have base 16. So we have base, okay, let's make it clear. Base 2 uses 0 and 1. Base 4 uses 0, 1, 2, 3. Base 10 uses 0 to 9. Base 16. Does it use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16? No. So see the figures making up base 16. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Because in number bases you can't have two figures at the same time. So you can't have 10. You don't have 10. So from 9 you have the next one is A, B, C, D, E, F. So if you go ahead to count the number of figures, it's 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is base 16. Okay, so remember that we have this concept of bits. A bit is just a single figure. For instance, we have 0 is 1 bit, 0, 1, 2 bits, and so on. So let me just tell you the conversions we have. Just try to understand the points I'm making. We have one figure equal to 1 bit. Okay, 4 bits is called nipple sometimes, but it's not normally used. We have 8 bits. You guess it right, is equal to 1 byte. Okay, so base 16, that is made up of 16 bits. That is 16 bits. That is it. Alright, so sometimes this is referred to as hexadecimal. hexadecimal. So sometimes you may see something like FFF. Okay, so that's a hexadecimal number representing 15 times 3, but let's not talk about that. So just take note of the number systems. We have base 2, we have base 4, we have base 8, we have base 10, we have base 16. Those are the number bases the computer recognizes. And in a different video, I'm going to take time to explain these number bases clearly and explain a simple way you can convert from one base to another base. So for now, let's put away this mathematics and now discuss what really are the various programming languages we have. Alright, we are now going to discuss programming languages. There are several scores of programming languages, but in this course we are going to discuss maybe 2 at a time. If we discuss 2, then we go ahead to the lab to use that programming language to actually write a simple computer program, and you see how it works. I'm thinking I'm going to discuss it in the order of popularity. For instance, we are going to discuss the first one we are going to discuss. Let's just start discussing them. Is the first one that is very much popular, or the most popular programming language is SQL. SQL is also a query language. Sometimes it's not classified as a programming language. Why is it the most popular? Because SQL is actually can be used by every other programming language. What it means is that this programming language can work in conjunction with Java, with C#, with C++, with every other programming language. And why is it that way? It's a special kind of programming language called structured query language. Yes. So it's called structured query language. It was developed by, I think, by a computer programmer named Chamberlain, and a second one called Raymond. That is in the 70s. Yes, in the 70s this programming language was developed, and since then it has been the most popular programming language because it handles databases. So what really does it work for? SQL cannot necessarily be used to develop a computer application. You can't see an application, maybe a game or maybe some other utility application and have that this application was developed in SQL programming language. No, it doesn't work that way. SQL is a language written only or specifically to communicate with the database. So if you don't have any need to access the database, you likely will not have any need for SQL. If you are only writing a program to interact with the user, to get user input, give user outputs, or maybe display some graphics on the screen, you likely might not have to work with SQL. And now, SQL, the structured query language, the syntax helps you to either manipulate the data in the database or to define data in the database or to do some other things. But the main ones are, the first one is DML and DDL. DML stands for Data Manipulation Language, is a subset of SQL, and DDL stands for Data Definition Language. So what it means is that you can write a DML query, can also write a DDL query. For instance, you may have something like create table. Create a table in the database. A table that is not existing before is created in the database. Automatically, you come to understand that this is DDL, a DDL statement, because you are defining a data that has not been there before. Then DML is data manipulation language. For instance, if I have my name to be Kindson and I have my surname, okay, so let's assume I change my first name, okay, so you may have a query that goes to the database to make that correction for you, and that is, sorry, you are manipulating the data by changing this. So assuming my name changes to I want to make change to my name to something like Kani. So the query will look something like updates the first name, blah blah blah. So this is a data manipulation language because you are manipulating the data, you are making updates to an existing data. So SQL is a most important programming language because at each point in time you are developing an application, you must store your data somewhere. Some have wondered, why do we not just store our data in memory? Why do we not store our data somewhere on the page or something like that? The reason you can't do that is you need your data to be persistent. You need your data to be secure. SQL provides a functionality to provide secure data storage in the database. So a database provides a functionality to securely store your data, persist it across multiple locations, across multiple users, so that you come next time and you have your data. So when you go to your Facebook, facebook.com, you enter your email, you enter your password, it goes to the Facebook database and pull out your data and displays. Although I know of Facebook query language, but that is a totally different thing altogether. The important thing is for you to manipulate data, for you to store data in the database and be able to retrieve those data back and use it, or maybe for you to make changes to data and save back your changes there, you need SQL. So SQL is the one of the most important programming language. That is why I list this as the first one, a structured query language that is used to access database and used to modify database. Alright, so in the next presentation we'll now discuss the next programming language, and that is HTML. Alright, today we've discussed a number of things about computer programming. The first programming language we discussed was SQL, a structured query language, a language used to access your data in the database. Now we are going to discuss HTML. That is the second language we are going to discuss. HTML. Let me just make this difference clear. This is a query language. And this is a markup language. I'll explain in a minute. So HTML is not a complete programming language, as it were, like Java or C++. It's sometimes called a markup language. What it means is HTML contains markups that are arranged in certain order, and then the system understands it. HTML was developed in 1993 by the W3C, that is the World Wide Web Consortium, a body responsible for regulating the World Wide Web. So it was developed to control display of data on a web page. Okay, so it's a language used to develop the World Wide Web. The HTML language is a language of the World Wide Web. Take note of the full meaning of HTML is called HyperText markup language. So we have this HyperText ML. HyperText markup language, a language for the web. In the days of early days of the internet, we have the server and we also have the client. But the developers wanted a situation whereby people will be able to access resources in a central computer from anywhere they are. So when networks were created, along the line, they have to provide a language that helps people to access data on the server. So we have the HTML language that helps you to access data that is in the server. So HTML runs on your browser and then is able to access data on the server. It defines the appearance of the page. Now we are saying that HTML is a markup language, meaning that the language is simply made up of just markups. Markups means tags. Tags come in pairs, opening and closing tags. After now, we are going to the lab work and we actually have to write HTML codes. A very simple one though, and we're able to use it to create a simple HTML page just from the scratch. So HTML tags are something like this, HTML. And then we have the closing tag /HTML. So in the HTML page, you always see the opening tag and you see the closing tag. We also may have other tags in between. But one thing I want to let you know is the basic structure of a HTML page. There are 3 markup tags that has to be in every HTML page for it to be viewed as complete. The first one is the HTML tag. The second one is the head tag. Of course, you have /head. And the next one is the body tag. The body tag. And you have /body. Okay? So, and then remember the tags come in pairs. So if you have HTML, you must have HTML at the end. You have head, you should have head, body /body. So we now have /HTML. So that makes it a complete HTML page. So the important thing I want to let you know is HTML is the language of the web. That makes it one of the most important languages, although it's not viewed by some as a programming language, but since it's used to write programs written in high-level language that the computer interprets, we can call it a programming language. Another interesting thing about HTML is that it can contain other languages. So what it means is that, let's say you have a program written in Java, it can be embedded inside the HTML page using tags. So what it means is that you may have inside the HTML, you can have scripts as a tag, and you have /scripts. So it means that in between the script and /script tag, you have code written in a particular script. It may be JavaScript, it may be VB script, it may be jQuery, or it may be some other kind of script. Another thing is also that you can embed pictures inside HTML programs. Everything you have to do has to be inside one tag or the other. You can have something like object. You can have something like image, and so on and so forth. So this is about HTML, but one thing I want to let you know is that this word HyperText, where does it come from? Pay attention to this explanation. HyperText have to do with a text linking to from one page to another. So if you have a page 1, sorry, let me put off all of this. So if you have page 1, and then you have a link inside page 1 that takes you directly to page 2. That is the concept. So we have a hypertext, meaning that the text is not static text, or it may be static text, but it can direct you from one location on the web to another. Not just page, it might direct you from one location directly to another location, from one website to another website. So the concept of links, having links inside your website or inside the page, can actually make it a hypertext. So when you type in Microsoft Word, the letter blah 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 is not a hypertext. But when you have a page that contains links, that becomes a hypertext page. So if you browse a website, you see several links, you can always click on one link and it takes you to another page. That is the concept of hypertext, and that is what makes the HTML language a very, very important language. Think about it. If you want to use a website, do you buy a manual that helps you to understand how to use a website? No, you don't buy any manual. You simply start clicking on any link you see, and it takes you to where you want to go. So that is the concept of I'll just write this word. I'm not going to go too far into it, but let me just write it. I'm going to explain it at a different video. So haters, the important thing hypertext as the engine of application state. Hypertext. Okay, sorry, I'm getting it wrong. Okay, so this word is an important word for every web developer, especially if you are building an application that runs on the web and connects a number of organizations. Hypertext as the engine of application state. Hypertext as the engine of application state. What it means is that what controls the application state, what controls the user of the website, is the links. So you simply start clicking on the links of the website and you are using the website. You don't need an explanation, you don't need a manual. So that is what makes hypertext so powerful, the links and the hypertext. But one thing I want to warn you about is that if you see links on your email, it's safer not to click on those links on your email. If you can type out the link on your browser, good. If you can right click and copy the link and paste it somewhere else to examine it, good. But avoid clicking links on your email. You can click links on your web page, but avoid clicking links on your email. That have damaged many computers, because you can click on this link and it automatically starts running a malware or some script that will collect your data that can even crash your computer completely. But in websites, hypertext, that is links, it's very, very important. So we've discussed two programming languages, SQL and HTML. What we are going to do now is that we are going to go to the system. We are actually going to physically write SQL queries to query data in a little database we are going to build, and we are going to use HTML to build a simple page just to see how the HTML tag works. So let's take a brief rest, and when we come back, we now do the lab work of about 15 minutes. Alright, this is a 10 minutes hands-on lab. The first one we are going to go through is going to be really easy. So what we are going to do is that we are going to follow these steps. First is create a database in MS Access. Write SQL query to insert data into the table. So the first one, write SQL query to update data in the table. Write SQL data to delete data. So this is what the lab is all about. So the same queries you are writing in Microsoft Access is exactly the same query that you also use in MS SQL Server database. So never mind if it's Access. You can also install Microsoft MS SQL Server Management Studio, but that you don't need for this lab. So let's go ahead to follow these simple steps. So what we are discussing is SQL query language. We want to make sure you understand how it works. So let's take the first step. Let's create a database. So if you have Microsoft Access 2007, 2010, 2013, either of them, or even higher. So let's call it a lab 1. That's the name, lab 1 DB. Okay, so create. Alright, so at this point we've created the database. I think we have step 2 should be create a table. So the first one is done. We've created a database, and that is how easy it is to create a database. So let's go ahead to create a simple table that holds the names of students. So when you open a new database, this is what you see. So what you are going to do is to right click on that table 1 and click on design view. It prompts you for a name, call it TBL student or any other name you would like to use, and just say OK. So at this point it displays this design view you see here. So it has the first one, the ID. Let's leave it there at auto number. Let's enter the first field, or the first column should be first name. It will be text. The second one is last name. Carefully follow along, this is really easy. The next one is dates of birth. Always give the name to be having no space. Under the data type, just make sure you select date and time, and then age. You have a number. We have a number, and that is just fine. Alright, the UPS is beeping. Let me try to make sure I switch off so that. Alright, just switch off this thing. Alright, so at this point we've succeeded in creating our tables. So go ahead to click on save, and it saves perfectly. The next thing you are going to do is to go ahead to close. Right click on it and click on the close button, and it closes. So now we've completed the step 2, and that is we've created our table. Done. So let's go ahead to now do the real work, writing SQL query. Writing SQL query is really very easy. So what you'll do is that you click on the table and go ahead to create. Okay, if you click on the create tab, then go ahead to query design. Go ahead to query design. If you go to query design, you get this dialog box that says show table. Go ahead to say add. If it's one table you see it there, you just click on add, and that is fine. Now we can actually design our table here without writing any single line of code. But what we want to do is we want to write a table to insert data into the table we created. Now let's take a look at the design view of the table again. It says ID is auto number. ID is auto number, meaning that the ID is automatically generated and we don't have to worry about it. So let's go ahead to close. So the table we've created is existing, and we now have to write SQL query to insert data. If you go down to the lower part, you'll see these icons here. You have datasheet, you have a pivot table. So what you are going to click is the second to the last one that says SQL. As you can see, SQL, and that is just fine. So when you click it, it gives you a blank space, completely blank space. Okay, so it gives a completely blank space, and then what we are now going to do is to write the query. So what you do to write a query to insert data is this way. It simply starts with insert into, okay, the name of the table follows TBL students. Okay, I want to insert, specify what you want to insert. First name, last name, dates of birth, and age. Okay, so this is what you specify in the first line. In line 2, just say values and give the first name, let's say kind son, comma, enclose in single quotes mononye, comma, date of birth, let's just say 02 20, okay, 1982. Okay, all right, so age is 34, and close it. So if you've written it this way, it will be okay. So we've written the first query. Let's make sure it runs so that we'll check whether this data is inserted. So go ahead to click on the create tab. Sorry, not on the create tab. Go ahead to click on the query tools. Okay, on query tools, and go ahead to click on run. It tells us you are about to append one row. Click on yes, and that is fine. So having done that, let's check if the data is inserted. Go ahead to right click and say open. So you can see it's inserted there. Alright, so let's just try to change the values again to something else. Let's say Leander, Yuba. Let's just change to something else. Let's just write something else. Alright, so what we are going to do, go ahead to click on design, run. Yes, okay, so we've written a query to insert data, and if we check, we go ahead to open, you see that the data is inserted. So what we actually wrote here is SQL query. So you can actually copy this or try to save it so that you might use it later on. After now, we are still going to save this as insert query. So let's go ahead to save. Go ahead to click on the save icon, save, and call it insert query. Okay, that is fine. Alright, so we have an insert query here. If you double click, it tells you it does not what we want to do. So the next thing we are going to do, we want to write a query to change. Let's complete this. We've written a query to insert. So the next one is to write a query to update. Let's assume that I want to change my first name to something else. Let's say I want to change my first name from Kindson to Kani. So let's now write a query to do that update. So what you'll do is go ahead to click on create, query design, add the same process we followed, close it, and then go to SQL. So what you'll do is you write the update statement, updates TBL students. Okay, so now we are changing the first name to something else. Set first name equals Kani, where first name equals. So this is the update query. If I run it, it's going to update to change the first name to Kani where the first name is Kainton. Sorry about that. So let's go ahead to click on run. It tells me you're about to update. I say yes, I want to update. So let's go ahead to look at the table again. Open. You say first name now is Kani. So the query worked. So let's go ahead to save it as update query. So let's go ahead to click on save and call it updates query, and that is just fine. The next one is let's check off this one is done. Write SQL statement to delete data. So let's go ahead to close this. Go ahead to click on create and then query design, add and close. Go ahead to click on SQL view and just say delete, because it's a delete statement. We are writing delete. I'm going to explain what the symbol star stands for after now from TBL students. So I want to delete my record where first name equals. Okay, so this is a simple delete query. What we are writing is SQL statement. So if I click on run, you're about to delete one row. Yes. And if we go ahead to check, we find out that maybe one row is gone, just one remaining. Alright, so go ahead to save as delete query. Okay, so that is the three queries we've written. Let's quickly write a different query, this time a query to select data. Go ahead to click on create and go to query design, add, close. Go ahead to SQL view, and of course this select query is already there. If we run it, you must have at least one destination field. Okay, just specify after the select, write star and then run it. It's selected. So let's go ahead to save this as so call it select query. That is the name of the query. So pretty much everything about SQL has been done. We have the insert query, we have the delete query, we have the update query, and we have the select query. Alright, so if you have followed carefully, you find out that it is really very easy. So the next one will be, we are going to now develop HTML page, a web page using HTML. Right, this is a lab 2. It's a 10-minute lab, and we are going to work with HTML page. We are going to actually learn the actual HTML syntax. So what you are going to do is, the first one, you open Notepad. So go to Notepad. Make sure you follow carefully exactly what I'm doing. The next thing you are going to do is to save the file as the name lab2.html. Of course, you can use any name you want. I want to save on the desktop. I would like to save in a folder called programming. Okay, let's just say programming. That's the name of the folder I'm trying to save it. So open. So here is very important. File type, click on save as type and choose all files, and then give it the name lab2.html. Okay, and save. So what I want you to do now is to verify let's just check out what we've done. We've done this. Alright, so verify that the file is saved as a web page. So let me go to my desktop and then go to the folder I saved it. Remember, I saved it as inside this programming. So you see lab2.html, 0 bytes. See, type is a Google Chrome document. The reason is Google Chrome is because Google Chrome is the default browser I'm using. Can actually change to Microsoft's Internet Explorer. So you see is a HTML file. As you can see, the file type. If you go ahead to double click, it actually opens in the browser and nothing shows there. Okay, so that is, sorry for that. I'm trying to swap this. Okay, so let's continue. Let's go ahead to complete it. Verify. I verify that the page is saved as HTML. So the next thing I'm going to do is to write the HTML head, title and body tags. So just follow along carefully. HTML, no space, about 10. Remember, it always has a slash. The tags always come in paste. So the next thing I'm going to write head slash head. Okay, so at this point the next thing is body slash body slash body. So try to follow, you find out it's very easy. So at this point I'm going to save and I'll go, let's check how far we've done. Okay, we've done this. Alright, so write and verify the title. So let's write a title inside the body tag, inside the head tag. Remember, the title will always go inside the head tag. Title, give some space, slash title. Okay, so what you are going to do now is write something inside. This is our second. Okay, let's just say this is HTML lab from KTT Pro. That is me. Alright, so save and verify. Save and verify. Save and then verify. If I go to this folder and I open it up, take note of something. Remember, this is where the title comes in. So the title is actually what comes in the title bar, is not what comes right there in the body. So we've made some progress. We've done this. We've written a title and we verify done. Alright, so make sure you follow along. Write some content in the body section. This is the body section in between the two. Welcome to this lab on HTML. Okay, and that is just fine. So let's file, save, and let's just go ahead to right click and just refresh. Refresh will be okay. Refresh. So you see, welcome to this lab on HTML. Let's try to put the tags h1 and then slash h1. So go ahead to save and then refresh this page. You find out it's really big. So let's try to try down on your own. You can try to use h2, h3, h4 and see how it appears. Let me try to use a tag called center and slash center and see if it's going to centralize. the content. Okay, I need to save, refresh. Okay, and that centralizes it. So try out every other any other tag. We've done this. So gradually we've completed our hands-on lesson on HTML. In the next one we are going to do something a little more advanced, but the focus is for you to understand that it's not difficult to work with SQL. It's not difficult to write computer programs. It's not difficult to create HTML pages. This is really the foundation, and this is exactly how every other thing looks like, except that you have to add more codes. But most applications now, you may not have to start writing all these codes. It's already being generated for you if you work in the design view. So I'd like to thank you for viewing. Let's just conclude this course, and then we continue with the next course.